Hi guys, my name is Peter C. Dogba Junior Mathematics Instructor at the University of Liberia and your math tutor. And in my today's video, I will be discussing finding derivatives of functions by means of the methods of differentiation. So in other videos, we did finding derivatives of functions by means of the first principle of derivative or the definition of derivative. So for this example, we want to look at, now this is example number 2. So we want to look at, in this problem, we want to look at the derivative of uh, some functions, and particularly we want to focus on the constant multiplier rule. So in relation to the constant multiplier rule, we'll be looking at some linear functions. So all of these are all linear functions, and we want to find the derivative of these linear functions by means of the methods of derivative, which we're going to apply the constant multiplier rule. And the constant multiplier rule says if y equals to cx, then y prime is equals to c. So if y is equals to a constant times a variable, then it means that the derivative of that function will just give us the constant. So you can check my previous videos, we derived that particular rule. So just Google Peter C. Dogba Jr. on YouTube, and then yeah, you will get the remaining videos. So now we have example 2, and I said example 2 because in the previous example we did finding derivatives of constants. So this one now is linear functions. Now the first example says y equals to 4x. Now the power of this x is 1. So if we apply the power rule, which says if y is equals to x, then y prime is equals, or if y is equals to x raised to the power n, then y prime is equals to n x raised to the power n minus 1. So if we have y equals to 4x raised to the first power, then we can say y prime equals to 4. We rewrite this 4. This power, like you see, n, we bring this power down, we multiply it by this 4, which is 1. Then we subtract 1 from the power, so it's 1 minus 1. So we have y prime to be 4 times 1 is 4, x raised to the power 1 minus 1 is 0. So when a variable or any expression that is raised to the power 0 is just equal to 1. So it's 4 times 1, which is 4. That's the reason why we said if y equals to cx, then the derivative of cx is just equals to c. So if y equals to c, this is c, this is x, then its derivative now is just equals to c, which is the 4. So in this case, this is our c, this is our c, this is our x. So f prime of x would just be equals to minus 1 over 2. Or if we want to derive at it, we can put little 1 on top of that x. So we rewrite minus 1 over 2, and we drop this 1. We rewrite the x, and we subtract 1 from this x. So it's 1 minus 1. So f prime of x will just be 1 times 1 is 1. And then x raised to the power 0 is just equal, this is just equal to 1. So we will have f prime of x now to be minus 1 over 2 times 1, which will just give us minus 1 over 2. So that is a derivative. Now this one, g prime of x or g prime of t. Now this is equal to, now so the first term we're going to use the constant multiplier rule. The derivative of a constant times a function or a variable is just equals to that constant, because this is now c and this is x. So if we still want to apply this method, it means we can put a 1 here, or and then rewrite this minus 5. Bring this 1 down, 1. Rewrite t and subtract 1 from t. 1 minus 1 is 0. So this is now 5 times 1 is 5. And then t raised to the power 1 minus 1 is 0. So we will have g prime of t to just be equals to minus. Now, t raised to the power 0 is 1. So it's just minus 5. Now, if you look at this second portion, we told you the derivative of a constant is equal to 0. But if you wish to probably, understand the steps, or want to know why it says that it is equal to 0, you can attach a variable. And we are attaching t because the independent variable within this function is t. If this was x, we would have placed x. So we raise it to the power 0 because t raised to the power 0 is 1. And 2 times 1 is 2. So we apply the property now. So it's 2. We bring this 0 down, 0. We rewrite t using this power rule and subtract 1 from t. So it's 2 times 0, again is 0, times t raised to the power minus 1. So 0 times t is just 0. So g prime of t now will just be equals to minus 5. So all of these steps that we took were just intended to, make you to further understand how we arrive at our answer and why we said that if you have 5t, the answer is just 5 or so forth. But you can just take this problem from right here and just get your answer. The derivative of a constant times a function is just equals to the constant. The derivative of a constant is just equal to 0. So this is just your answer. So thanks ever so much for watching. See you in our next video.